Another part that analysis that makes is complex is related back to that channel water source elevation, interior elevation, water source elevation, kind of the fact that the water source elevation of the channel isn't necessarily the same as in the floodplain. We talked about the need to develop a breach hydrograph, take an event, get a breach hydrograph, look at that volume and how that fills the area. But one of the challenges is that, we don't have floodplains that are just a nice, simple bathtub. We want to make sure we're accurately capturing the water source elevation at each and every one of the structures. And so what we've had to do is take our impact areas and subdivide them. Early on, we represented these areas using 1D models, so different storage areas. And so storage areas, for example, in UNET and then in RAS, where we developed unique interior-exterior relationships for each of these index points to impact area, sub-impact area relationships. Now, as we have more information and more refined tools, we use detailed two-dimensional modeling, so RAS 2D and previously Flow 2D, to develop floodplain surfaces. And so we're able to develop, instead of just a simple interior-exterior relationship, there's a way to use HEC-FDA to develop a channel elevation to floodplain surface relationship and feed that directly into the risk analysis. And that really becomes important for an accurate accounting of the expected annual damage for areas where the interior area of the floodplain is sloped and not just flat. Another part of the analysis that is complex is that we have a changing structure inventory. We've got a lot of, Sacramento, Yuba City, Marysville, surrounding the area. There's a lot of growth, and so we have to make sure we're keeping our structure inventory updated. And so, we can sample the inventory, for example, in 2000. Well, after a few years, there might be a lot more structures that have been built, kind of rapid construction, and we want to make sure that we're accounting for that within our flood risk analysis. We also want to make sure that when we do that, we're considering the National Flood Insurance Program participation, that future development isn't increasing flood risk at more events common in the 100-year. And so we want to make sure that we're analyzing flood risk, capturing all the structure inventory, capturing the future inventory that's going to be built, and make sure we fold all that into our expected annual damage. And so one of the ways we do this is, again, in our analysis, we compute a expected annual damage based off our current inventory, but then use approved development plans and specific plans to look at how much development there might be in 20 years and compute flood risk for that as well, and to fold that into the analysis. Again, there's different rules on how to include that in the analysis, but again, part of the effort to make sure that we're capturing the flood risk analysis current and within the future time frame. Another part of the analysis that is complex is within the Central Valley. We've got a very elaborate flood response and emergency preparedness system. So we've got the Department of Water Resources works collaboratively with the National Weather Service, the Corps of Engineers, to provide advance warning to flooded communities or potential flooding to communities. A lot of investment's been put into the emergency response planning and system. And so we want to make sure that we're capturing all the great value and benefit of our flood warning system and flood forecasting system in the flood damage analysis itself. And so we don't want to just assume that flood warning time isn't there. So early on in some of the analyses, we actually used what's called the day curve, which was in various studies, research done that relates flood warning time to the percent reduction in damage. We went through and worked with emergency responders and forecasts to get warning time estimates at the different impact areas in the system, and then modified the expected annual damage accordingly to account for the fact that furniture and property have been moved and reduce the damages. But from the comp study effort, that initial effort was rejected by headquarters and said, that's not really rigorous enough. You need to do something more refined, more site specific to account for the impacts of the flood warning system, and especially if you're looking at alternatives, non-structural alternatives, looking at improving the flood forecasting system. And it's especially important to make sure we're making a distinction and doing a detailed study of what the real benefit of that is. And so actually, we relied on expert elicitation. We started with the cores, the depth damage functions, and then surveyed experts and said, if you had 1 hour of warning time, what might you do? And if you had 6 hours of warning time, what might you do? And how much damage do you think you could prevent by taking some of the high value televisions and put them upstairs, or actually evacuating them? And so we developed specific depth damage warning time relationships that are applicable to residential content. We kind of didn't try to say that we're going to stop the structural damage, but at least the content, and develop these relationships. And we're able to fold those directly into the risk analysis. There's actually been a technical paper and procedure written up on this and published in the American Society of Civil Engineers. And this process was accepted by the National Weather Service and the USGS as well. So there's more information available for those interested.